Here's a past paper problem involving vectors. We've got three vectors, L, M, and N, and we're given their values in terms of I and J. What we need to do is find the magnitude and the direction of the resultant of these three forces. Pause the video, and whenever you're ready, unpause to have a look at the worked solution. So what I'm going to start by doing, I'm going to write them as columns just because I find it a little bit easier to add things together then. So L is the vector 2, 5. M is the vector 3, minus 22. And N is the vector 4, minus 23. Now I've already written add symbols here. That's because I need to find the resultant. So that I know that I'm going to need to add these things together already. In order to add these, I'm just going to independently add the i's and the j's. So I'm going to start by adding these values together. 2 plus 3 plus 4. And that will give me 2 plus 3 is 9. 5 plus 4 is 9. And if I do the same for the j's, I've got 5 take away 22, take away 23. Now, what's that going to be? Minus 17, take away another 23 is minus 40. There we go. And of course, if you wanted to, you could write that as 9i take away 40j. Now, in order to find the magnitude and the direction, I'm just going to try and plot this out a little bit, draw what I think it should look like. So a vector that's 9i minus 40j should go 9 units across and 40 units down. So it's definitely going to go down further than it goes across. Let's try and add a little dotted line in here as well to indicate that it is a right angle triangle. So we've got right angle there. This cross is 9, the 9i, and down here we've got 40j. The magnitude of the vector is the hypotenuse of the triangle. So I'm going to use Pythagoras to get this expression here. So I will 9 squared plus 40 squared. And by the way, if you wrote it like this, it's going to work out exactly the same anyway. It doesn't really matter. I'm going to need to put that into the calculator, I think. Let's see what this comes out as. I've got the square root of 9 squared plus 40 squared. Oh, that's quite nice, isn't it? Got a magnitude of 41. That is our magnitude. And for the direction, I need to consider the angle that it makes with the I direction. So if we had our axes, they would be along here. And I'm finding this angle here. The direction will be a negative quantity because it's under the axes. Let's see. So in terms of my sides that I know the opposite and I know the adjacent. So I'm going to use tan. And I'm going to replace the opposite with 40, the adjacent with 9. And then I will use inverse tan to get my angle. And once again, that's going to need to go in on the calculator. Let's see what that is. I'm going to shift tan, 40 over 9. And that's going to work out as 77.3 degrees. Cool. Once again, though, because the direction is it's in these negative quadrants, I'm going to have to state the direction as a negative value. So the direction minus 77.3 degrees compared to the I direction. There we go. Brilliant.